And thanks, Paul, for all the hand-holding. I appreciate it. So my name is Terry Ryan, and I'm a developer advocate for Google. I basically do outreach to application and development groups, specifically in the language PHP. And that's enough about me. I want to know more about you guys. So who here, I assume everybody in the room is a PHP developer, right? Anybody not? Anybody like JavaScript guys sneaking in? No? All right. Anybody here also moonlight as a designer, maybe? Do design work? OK. Does anybody here also do a lot of systems work? Right? OK. So you do both. Is it because you love DevOps? Or because your company hates you and don't hire more people? I see some hands. All right. Any managers in the room? Do you manage people that are in the room? Good. We can make fun of you. Without, damaging your authority or anything. All right, so let's see. How many people here are already using Docker and other container technologies? OK? So let's go the other way. How many people here are not and just aren't into the whole Docker thing? You haven't sat in a room where someone screamed Docker at you for an hour and converted? All right, so it sounds like from what I see in the room, I don't necessarily have to go over containers. We can get right into why you would want Kubernetes. Anybody here really want a container overview? No? It's OK. All right, good. All right, and how many people here have played with Kubernetes already? OK. All right, we'll see if I have useful information for you. All right, so let's start. Why Kubernetes? Why do we want this thing? So what problem are we trying to solve? So let's set up a scenario for you. I have switched to Docker, so I'm running my app in Docker. I have right here a two-tier application. I have my front end and services written on an Nginx PHP Docker container. And then I have my back end, which is running MySQL. And we're all set, and this is our environment. If I need a little bit more horsepower on the front end, on the services and the front end, I can add a couple extra Docker containers. But someone might point out to me that this is really not the containery way of doing things. Because if I look at my front end and services, my front end is all HTML, JavaScript, CSS, and my back end is all PHP, and there's no real mix of the two. It's almost like I wrote it knowing I'd want to split it apart into two things. So I'm going to do that. I'm going to be containery, and I'm going to say, all right, just services are running on this Nginx PHP Docker container. And then my front end, I'm going to switch this to just be Nginx. So no PHP, just serving up HTML, JavaScript, CSS. And then my architecture is going to look a little bit like this. OK, so far, so good. Someone else will point out, hey, containers, you're running your database in a container, and that container can just go away at any time. And database and ephemeral, not words you normally want to hear in the same sentence, right? That's easily solved in Docker. We have this ability to add a volume. That volume lives outside of the Docker host. Outside of the Docker container. And if the container goes down, it can a new container can reconnect to this volume and work. OK. All right, so now my environment's looking a little bit like this. If I need to scale out even more, I can do that. But all of this is just an abstraction. Because under the covers, we still have one machine, one Docker host that is running all of this stuff. So, and that's also bad, right? We kind of don't like single points of failure. It'd be nice to avoid them if we can. So what we're going to do is we're going to split this up into two Docker hosts. My volume lives outside of it. I've got my two Docker hosts. If something goes wrong and this machine goes down, I have to migrate all my hosts over. And that's a lot to manage. And this is basically what we have already. We've just added Docker to it. So that's that joke, right? I added Docker, and now I have two problems. Right? I added a lot of complexity, but I didn't make things that much easier for me, other than the fact that I can use Docker files and I can have very portable builds to do this. But I'm still managing a lot of it. So the answer to this is what we call container orchestration. Now, there are a couple ways of doing this. The way I'm going to talk about is Kubernetes, right? Because otherwise, I put the wrong title on my topic. On my talk. So Kubernetes approaches this from a different perspective. I give it resources, Kubernetes nodes, right, which are just machines. And that's all I have to do to manage Kubernetes on them. I just install Kubernetes and pretty much let it go. And then I tell Kubernetes, hey, I tell Kubernetes, hey, I want 4 of this container, I want 3 of this one, and I want 1 of that running all the time, and I want a disk. And Kubernetes will manage that for you, right? And that's the promise. That's the, that's the infomercial way of looking at it. So Kubernetes is a container orchestration system. It is open source. It was started at Google. Google has been doing container stuff for a while. And we have an internal solution that is not suitable for open sourcing, mostly because it relies on our infrastructure, which is highly customized. So the team behind our internal system, which is called Borg, and you can look it up, there are papers on it, they got together and said, hey, whatever we're going to do this greenfield, kind of making up for all the mistakes we made over the last couple of years that we've been doing this, and made it work with commodity hardware instead of our own. So we started it, but now it is contributed to by many others. We don't govern it anymore, although we're still heavily involved in the product. The other contributors include Red Hat, IBM, Microsoft. I don't know for a fact that Amazon does, but I'm fairly certain they do. Docker is also involved. So, and the largest contributors of any organization is unaffiliated. So most of the changes are now coming from people that are doing it on their own time and not on a company's time, which is really exciting. So I'm going to go through some concepts to help kind of what do we need to think about when we're thinking about Kubernetes. So the first is that all of these services are ephemeral. And anything I launch in a pod should be able to be blown away and I don't care, which means a whole lot of things. Someone earlier in the cloud native talk was talking about 12-factor apps. Just that, right? Like your apps need to be ephemeral. They need to be just dumb services that come up and go down and don't store state in the actual app itself. So we kind of know the old way of doing this, right? Like I set up cluster machine for redundancy, and I give them names. And if in the middle of the night they go down, we send Todd. Actually, no, we're in Scotland, right? So it's not Todd. It's like Ewan, right? Ewan or Ian. He goes down and he's up all night fixing it. That's not how we work with containers. The idea in containers is cattle, not pets. Have people heard this before? See some shaking heads. So cattle, not pets says, look, if you have a pet, it has a name, it is unique or rare, it gets personal attention, and when it gets ill, you stay up all night making it better, right? The other way of running stuff, and what we're going to do in Kubernetes is cattle, right? It has a number. We don't really care about an individual install of our code base. One is pretty much like another. If I have 12, one of them goes down, I bring up another one, that's fine. We run them as a group, so we run a fleet of containers instead of just one. And if it gets ill, you make hamburgers, right? Now I realize where I am, right? And like, guys, no, please, if cows get sick, don't make hamburgers from them. We've learned that lesson. It's fine, make a leather coat. I'm not really an animal husbandry expert, so. But you get the idea, like just move on, right? So another concept is desired state. Desired state, so let's go the opposite, which we call imperative or kind of script-based, right? I create some Docker images, right? And then I launch the backend, right? I launch the backend first because if MySQL isn't running and I go to run the other stuff, I'll get errors because I haven't written my code with 12-factor app. Then I launch the services, and then I launch the front ends, right? And I do this all sequentially. And if one of these machines was to go down and no one intervenes, nothing happens, right? So to fix this, some person, that looks eerier and more ominous than it should. I should change that transition. But like some person has to get involved, right? With desired state, you say there should be 3 front ends, 2 services, 1 back end, and you launch, right? And I don't care if what order they come up. I've written my code such to handle the database not being up yet. And if one of these machines goes down and no one does anything, it comes right back up, right? Because it's been told that there should be 3 of these running all the time. All right, so I liken this, pets, not cattle, or cattle, not pets. Employees, not children, is how I'd term desired state. So with employees, right, like let's say you have a really tough day at work, stuff is bad, you can tell your employee, we had a tough day, go home, get some sleep, right? It could be, it doesn't have to be necessarily a boss, right, telling you this. It could be, just coworkers. But yeah, go home, get some sleep, right? They may or may not go home. They may or may not get sleep. But the idea is they will come back the next day, in most cases, hopefully, ready to work the next day. Those of you who have children know that no, right? Child, go upstairs, take off your clothes, put on pajamas, brush your teeth, pick out stories. Now, those of you, anybody here don't have children? Yeah? All right. So you can maybe be saying, like, do you really have to go through all the steps with the children? Like, yes, you do. Look at the first step. If you don't tell them to go upstairs first, you will end up with a naked child in your living room. And like the script-based thing, you'll see things you don't want to see. So we want our servers to act more like employees, to just go home and get some sleep. OK, so components. This is where I like basically just talk a lot of definitions at you. There is no way around this. Kubernetes has a lot of semantics and words that mean things. So I'm just going to try to get through this as quickly as I can. I put a demo in the middle of it to make it a little less just me saying concepts. But let's get to it. So first, Kubernetes is made up of nodes. Nodes are the servers that runs Kubernetes. Containers are going to run on these. And you don't necessarily, once you're running Kubernetes, you don't really mess with them too much unless you're really doing specific things. They can be hardware, they can be VMs, they can be, I have seen people do, and like I'm getting an aneurysm just thinking about it. I have seen people run Kubernetes inside a container running on Docker, running on a VM, running on a machine, right? And I say, like, that's fine. You can do that, but like, when stuff doesn't work, like really, it's your own fault. But yeah, it could be hardware or virtual, it doesn't really matter. The next concept is containers. Now, if you're working with Docker, this is a Docker file and a Docker image that you're used to. Kubernetes uses Docker. Under the covers, it's using Docker. This, sometimes our marketing people try to like downplay that, but it's Docker, right? Like Docker is running the container system itself. Kubernetes is handling scheduling and making sure stuff is all running, and it's handling a different set of problems. So Kubernetes uses Docker. I often develop using Docker locally, and then even though there is a way of running Kubernetes on your laptop, and I'll talk about that in a little bit, but I tend to just develop in Docker because there's very little change you have to make, and it's all outside the Docker file. So whenever I need to make changes to stuff, I make a configuration when I load it to Docker or Kubernetes, not in the file itself. But we call these subatomic in Kubernetes because they're not what you're actually, it's not the base unit. Like you don't run a container in Kubernetes just semantically. You run this concept called a pod. Now a pod is the atomic element of Kubernetes, and it can be made up of one or more containers. So they share, all the containers inside one pod will share an IP address, will share a local storage directory space, and a namespace. It's okay to have just one container. When you read the documentation, it'll talk about one or more containers, one or more containers, one or more containers. One is fine. It's totally fine. But there are legitimate reasons to run more than one. One of them that came up was someone, again, the talk was great this morning about Cloud Native, was talking about Istio, and that you run sidecar, an Istio sidecar next to your containers. So that's like the canonical example of this. A sidecar is a web server. So I have a web server, and it's getting, this is sort of contrived, but it's getting files from somewhere to serve up, right? So my web server should just be serving web files, right? It should be one container, just Nginx and a pointer to the local, the web files. But updating it is a different task. Ideally, and if you're going to be like, you know, a zealot about container hygiene, you're going to want those two separate processes handled by two different Docker files. So what you do is you write your routine that just syncs the file service in one and the HTML server in another, and then you combine them into one pod. And they act as the same system, but they're different tasks and different processes. Sidecar, ambassador, and adapter, basically it's, what's the purpose of that? So if I have like a logging server that takes it in a certain format, and I want to convert between what the container is expecting and what the system itself wants, I can do that through one of these adapter or ambassador patterns. And then finally, no one in this room, right? Your friends have had this happen where they set up a LAMP box just to try something out like 6 months later. It's like mission critical and you can't take it down. Again, no one in this room, people we know did this. If you're converting it to sort of a more microservice architecture, what you might do is split up the constituent parts, the PHP, the MySQL, and Apache. You might split them up into different containers, but have them on the same pod so that you can kind of gracefully move the development cycle over. Okay, so pods. I'm going to show configs for these, just to kind of let you see what they're like. If people hate YAML, I'm sorry. But this is what a pod looks like in a definition. The important things here being that I call it a pod, that I give it some kind of metadata, and that I'm pulling an image. In this case, I'm pulling Nginx PHP FPM latest. You probably shouldn't call latest, but let's just for these purposes, let's do it this way. And that's pulling it directly from Docker's repository. So when you type from image, that's the same exact, you can put anything you put there. And then I open up port 80 on the container because it's an Nginx server. All right, so the next concept is no one actually does a pod. You don't typically launch a pod. I mean, you can, but you typically don't because pods are dumb. Pods don't really know how many of them are supposed to run. When you say always have 4 running, a pod doesn't have any concept of that. So you have a control element on top of that. It's called a deployment. There are a couple advantages of deployments. They handle not just replicas, but how the machine handles, how the system handles updating. So if I look at that code, you'll see down to the bottom, I have pretty much the same exact pod configuration, but then I also have in there replicas too, and I have a strategy for how to handle updates, and it's just a little bit of control structure on top of that. So now, all of this has been ephemeral, right? This is all things that we don't care about, but at some point, you want to take this ephemeral service and hook it up with some sort of immortal resource locator. URL, a host name, something. So the way you do that is through services. So services define an endpoint. They get a virtual IP address. You can get a load balancer to make it public, and it's basically just used for exposing an application. For either other Kubernetes clients in your system or non-Kubernetes clients. So obviously, if it's other Kubernetes clients in the same system, you can have it be private. If instead you want it to be non-Kubernetes clients, you're going to have to make it public. So this is how this looks. This is a service. Some important details here. I say type load balancer, and on cloud environments, if you say just load balancer without any other information, it will request a load balancer for you. If you're on-prem with Kubernetes, you have to specify an IP address to point it to a load balancer. And you can, if you have load balancers already set up, even in your cloud environment, you can point them to specific ones. But in this case, I'm just saying, hey, I don't care, just give me a load balancer. I assign port 80 and port 80, so I'm basically proxying that through. And then at the bottom, I say selector app to do front end. And I'll show you why in a second. So, I'm going to do a demo because I got tired of talking about stuff. All right, so let me kind of show a quick demo of this. Please do not hit this URL. There's only one. You can hit this one up here, but don't hit the actual one because there's only one interface per container. So if you go to this host, you will take down my demo and make me sad. So I'm going to deploy a service. Right now, the service is not up. So if you hit this UK Wackapod IO API color, you will get nothing or an error. Because I haven't deployed the service. What I'm going to do is I'm going to deploy a set of pods, a deployment, that will throw up a random color. Pretty basic, but I want to make sure it's up all the time, so I'm going to make sure there are 12 of them. So I'm going to launch this deployment. I'll explain the hammer in a second. And so now I've launched a 2-node cluster of Kubernetes. And any moment, there we go, it's now serving up colors. Now you'll notice there's like a little yellow glow, but it's blinking. That's because I have a load balancer in this, and basically the one that's serving this up changes with every request. So the other thing is I can take these down, right? So I can start killing them. And when I kill them, you'll see that they go inactive, and then it launches new ones. And then eventually those new ones take over and fill it up. Now, one of the other things I can show here is what happens if the node goes down, right? So if the node goes down, I'm going to simulate that by knocking it down. You'll see that Kubernetes starts bringing them all up on another node. And if I kill the pods now, you'll see that it's going to respect that, and I knock down the server. Oh, no. On public Wi-Fi, this app, it has trouble. So the service is still up, and we can see that. I'm going to go and knock this one back into the cluster. And you'll see that as soon as I knock it back into the cluster, it starts accepting new assignments to it. So what does this mean? This means that I can run on a Kubernetes cluster. If one of the machines needs to go down, the service will remain up even though the node is down. And all I need to do in order to make a cluster start being able to handle new incidents like this is just add a node back in. I didn't actually kill the node and bring it back because that takes longer. But in a maintenance scenario, you can definitely do that sort of thing. So all right, so I will stop that. That was a quick demo of Kubernetes in action. And now we're going to talk about labels and selectors. So I talked about services. I talked about, and I showed you a deployment. I kind of glanced over it, but it created a service to expose all that stuff publicly. The way I do that is through labels and selectors. So here I have a whole bunch of different containers with a whole bunch of labels on them. These are completely arbitrary. They're just key value pairs. You can call them whatever you want. So in this one, I have app, tier, and environment, but you can easily call it different things. And then this allows me to select. If I want just the front ends, I can select just the front ends. And if I want just the prod pieces, I can select just the prod pieces. So then when I get to services, here's my deployment. Where is it? Did it fall off the screen? Let's see. OK. No, sorry. So it seems, oh, no, app, I'm sorry. App to do FE, right? So that's my label. It's completely arbitrary. And then when I get to my service, you'll see that my selector is app to do FE. And that's all I need to do to connect that service to that deployment. And then that'll serve it up publicly. All right? It's going to get a private IP address for that service. But in this case, it's a load balancer, so it's also going to get a public one. They're always private by default. You make them public through adding a load balancer. All right. Last sort of definition piece here is networking. So all pod IP addresses are routable. This is, if you're familiar with Docker, you know that pods can't talk to each other directly. You have to connect them through the Docker host. Two Kubernetes pods can always talk to one another. And they can do that without NAT, and they can do it even across Kubernetes nodes. So the entire system gets a complete network address that they can all talk to one another. So to sum up, Kubernetes uses containers, but they don't actually use containers. You launch these things called pods, but you don't actually launch a pod by itself because you need it to replicate and reproduce itself. So you need to do this thing called a replica set, which is part of deployment. But you don't do a replica set directly. You do a deployment, right, which is all served up by services, right? Simple, easy to follow, right? Uncomplicated. All right. So I feel like I need to address this. Why is this so damn complicated? And I actually took stuff out of that. I used to talk about a piece that we've now deprecated that is exactly like a replica set deployment. It's just complicated. Why? My explanation for this is, so this is the Kubernetes project on GitHub. You can see over the 3 years, you can see the amount of activity. Here is 1 month of pull requests for Kubernetes. So in 1 month, Kubernetes gets 791 active pull requests in December of last year. Not only that, but it's like during holiday time, right? Like during the time where most people are doing other things, 791 pull requests came through for Kubernetes. It is a very active project. It is still, like there are parts of Kubernetes that I rely on that are technically beta, right? It's still very, very fluid. It's still a moving piece of software. People rely on it, and you absolutely can rely on it. But that because it's so sort of active, you know, documentation changes pretty frequently. So now I'm going to show a little bit more of Kubernetes in action on a sort of bigger app. For the demo, stuff I did already. Already I have a cluster built. and have Kubernetes on it. I have disks ready. I have Docker images already built, and I have those images already built on a Docker repo. The reason why I don't do this in front of you is that, like, on really good Wi-Fi, like when I'm in the office, maybe 3 minutes. When I am not, like at a hotel or a conference Wi-Fi, can take over 10 minutes, and it's like not that interesting. So I figured I'd just yada yada it, show this, and move on to actually bringing up a Kubernetes app. So I have an app here. It is a 2-tier app. I did not break out into a 3rd tier. And it is, I know this is shocking, you've never seen anybody do this before, but it is a to-do app with, with Bootstrap. No one ever does that. So let me launch this. Well, let's do that. And I'm going to bump up the text, but what's happening here isn't necessarily that important. So first thing I'm going to do here is I'm going to launch a tool here that I'm going to show on the browser, which allows me to visualize all the pieces coming up. And then I am going to launch. I do not like typing in front of people because I am error prone. So right now I'm just getting some credentials and some property information, and now I'm just going to run a make file, make deploy. And nothing too crazy is going on. It's just going to send some YAML files to my Kubernetes server. So I'm not really necessarily going to bother showing that. I'm going to show this view of it instead, which should, assuming everything works, show you the pieces popping up, maybe. Maybe not. No. Do I have to refresh? No. So this is the danger. I'm running too many Kubernetes clusters here. So hold on, let me try this again. There we go. All right. So it would have been cooler. It would have popped up in real time, but you know, I'll take it because I'll do other stuff in real time. So my architecture here is I have a 2-node front end, and I have a service there that happens to be a public service. I have a private MySQL service that is serving up MySQL on the back end, right? All of this is hooked up. So let's play around with some stuff. So first thing I want to do is I want to look at all the pods I have. So I'll type kubectl get pods, and those are all my pods. Now, one of the things that I try to be very clear about is we don't care about individual pods. So I'm going to prove it by mercilessly killing one. Kubectl delete pod. Let me see if I can do this fast enough. There we go. We see one dies, but one comes back, and now we're up and running with 2 again. And that's, anyone know why it automatically came back without me doing anything? Anyone? Right, because we have a replica set. Good, you were listening. Just checking, make sure that I'm talking right. So let's go to the app itself. Now, this app wasn't up a couple seconds ago, but it is up now, and we see that, yep, I've done this a bunch of different places. I'm going to add a new message here just to show, well, I'm not asking hello. See, this is why I don't like to type in front of people. There we go, save, go back, and we see that's been added. Great. Now, again, this doesn't happen to just any, you know, you have to update code, right? Like, it is unfortunate. So in this case, our CSS people came back and said, the designers came back and said, like, no, like this light design is no longer cool. It has to be dark. So they've updated CSS, which is technically a code change. We're just, it's CSS, but it's a code change, right? So I'm going to go and update, and we should see this in real time. Oh, no. Oh, no, because I used the wrong. There we go. There we go. All right, and we should see this in real time. We should see, yep. So you'll see that nodes start popping up, nodes start going down, and Kubernetes handles that for me, and it did it rolling. It may have been a little tough there with the refresh on there, but if I switch back to this, now we're at our dark UI that's now cool and hip. So okay, so we're now going to take this down. We like to clean up after ourselves. So make clean, and we should see this. Pods go away. My services should go away. and the whole thing gets torn down. So, okay, so that is just sort of a quick, brief kind of play on what Kubernetes is and what it can do. And let's talk about some other issues. First question I always get, like, is this really the right way to set up a database? Not really. So remember I talked about all this and made fun of like the whole that is really complex? So I wanted to hide some complexity, so I didn't talk about a set of features. So basically what I'm doing with MySQL is I'm running a one replica set to just run MySQL. I have a volume attached. Kubernetes can handle all of that. But there's this other concept that I didn't talk about called a stateful set, which is very similar. But it's basically a pet set, and you add a whole bunch of extra information around the volume. So the volume information actually goes right into it. So here, if we look, this is my stateful set. It's pretty much, it's the same as the deployment with a couple key differences. One, I have this whole volume claim template, which what that does is it says, hey, the first time you spin this up, if it doesn't have a disk, add the disk. If you have the disk, reattach this container to this disk image all the time. And then it mounts it in MySQL var lib MySQL, so it becomes the data store for it. Now, why isn't mine using a stateful set? A couple reasons. Oh, I went through that fast. It's not a huge difference for MySQL because pet sets or stateful sets are actually used for databases where or stateful storages where each individual node is not that specialized. Just one has maybe a different role, and they all need disks and they all need to talk. So things like distributed databases like Mongo and maybe Redis and other technology like that. MySQL, you have to do a little bit more to get the nodes to talk to one another. So you tend to make only one in a replica set in a stateful set. So that's the first reason. The second reason is, as someone asked before, I'm not sure you should be running stateful services in Kubernetes. Now, somewhere there's a product manager at Google who's pissed that I'm saying this. Because no, you should run everything in Kubernetes, right? Everything should be in Kubernetes. But I don't think that's great advice. So let me qualify that with a little bit of explanation. So you absolutely can do this, and there are people that do it, and there are ways of doing this successfully. But I'm running MySQL, which Amazon has a managed MySQL service, RDS. We at Google have a managed one. I believe Microsoft has one now. You're seeing a theme here. If someone else will run MySQL for you, and all you have to do is do DBA on top of it, and the cloud provider will handle logs and maintenance and setting up replica sets. Like basically, if someone will do all the painful, like not fun MySQL stuff and leave you to just run MySQL, I would just do that. Right? And because either way, either you're going to run our Kubernetes cluster and we'll charge you for running on Kubernetes, or you'll run it in our managed service. Either way, you're going to pay for it. I feel like if you're going to pay for it, let someone else handle backups. So that's the first piece. The second piece is I think MySQL is more of a pet than, say, Redis, Mongo, some of these other services. So I think in many cases, those make a lot of sense to run in Kubernetes. But MySQL, I was going to say your mileage may vary, but your kilometerage, I guess, may vary. So that's it. So we also talked about rolling updates, we talked about persistent volumes, but there's a whole lot more, which would have made my Kubernetes complicated diagram a lot longer. Logging, monitoring events, web interface, config maps, so injecting configuration that the whole cluster can see. Jobs, secrets, which are like config maps, but they're encrypted. Horizontal auto-scaling. So I can say, I've been saying run 5 pods, run 12 pods, but you can easily just say, hey, run as many pods as it takes to make the processor utilization of those pods 80%. And then as your traffic goes up, your deployments will go up, and as it goes down, they'll go down. There's also Kubernetes, which is just fun, but we call it something less fun now, cluster federation. Basically, you can install Kubernetes on multiple, and all the nodes of a Kubernetes cluster need to be co-located in the same data center. But with Kubernetes, you can take 2 Kubernetes clusters that are in different data centers and connect them together and have them work as a logical resource. So what this means is that if you run on-prem and you want to augment with a little bit of cloud somewhere, you can do that. If you run on AWS and another cloud provider, you can do that. So you can really kind of fool around with where you're hosting your stuff. And the final piece is Ingress, which is really cool but very complicated. It is basically an L7 load balancer for Kubernetes. So instead of building individual services that I serve out through individual IP addresses, I can combine it all into one resource and have Kubernetes handle load balancing. All right, so comparison. So I get a lot of questions like, well, how does this compare to, say, Docker Compose or Swarm and all these other pieces? So let me preface this by saying I'm sort of an expert in Kubernetes, right, depending on who you talk to. I'm not an expert in Docker, so if I say something wrong here, I'm not lying, I'm just wrong, okay? So Docker Compose, you can put multiple containers in the same localhost, sort of similar to the pod concept. Docker Swarm, which does host basically allows you to do clusters of hosts, replication, orchestration, scheduling, and secrets. But that is now part of the Docker runtime, so it's just sort of just Docker. And then Docker Machine allows you to manage remote container hosts and launch container hosts in several clouds. Kubernetes is this set of that services. And then add to it that Kubernetes does routable networks, scheduled jobs, stateful sets, auto-scaling, and config maps. So this is generally how this shakes out. Docker comes from, it seems like their philosophy is like more Unixy, right? Like more separate individual tools that all talk to one another. Whereas Kubernetes is the big container orchestration solution that handles all of it with one set of apps. But I will concede this, Docker's logos are much cooler than ours. I really can't get around that. They hire an artist to make these. These are gorgeous. I wish, like you can see, this is like not a approved shirt because our stuff is mostly boring. There are all these ugly hexagons like this. All right, so I want to talk a little bit about Container Engine, which is hosted Kubernetes on Google Cloud Platform. And I've been mostly talking about developing on top of Kubernetes, right? I haven't really talked about running Kubernetes. And there's a reason for that. Let's go through that process. So I go to set up a cluster. And set up a cluster, I choose an infrastructure. I have no strong opinions on which infrastructure you should use. You can do it on premises, you can do it other places. And then you choose an OS, right? Core OS, Atomic OS, CentOS, Ubuntu. We used to run Debian by default, but now we run something called Container Optimized OS, which is open source, but it's done by us, and it's just a runtime that's really good at running containers, for lack of a better term. Then you provision the machines, right? So you boot up the VMs, you install and run your kube components. So you do that, and then let's see, you've got Kubernetes on those, and then you configure the networking, right? You have to get IP ranges for the pods, for service discovery network. So you set that up. Then you got to start cluster services, right? Like things like DNS and logging and monitoring. Then you got to manage the nodes. You got to handle kernel upgrades and OS upgrades and Kubernetes upgrades and hardware failures.
You really know how to sell it.
What?
You really know how to sell it.
Yes. Or you can go to Container Engine for Google, and there's just a little button that'll do all of that for you. Okay? So surprisingly, Kubernetes takes some system management to do, right? Which I may have been overselling there. But typically, the problem I think people run into is that, so I have to do a lot of work to install Kubernetes just to test to see if I actually want to use Kubernetes, right? I would say set up a cluster somewhere. This is one example of a way you can do it. And then figure out if Kubernetes actually solves your problem, and then worry about installing Kubernetes. So Container Engine is hosted Kubernetes. A few smart defaults are set, like a lot of the logging and monitoring and stuff that if you're very opinionated about those sort of things, you're going to want to set up yourself. But if you don't, or you're willing to use our solutions, they're already set up for you. And it allows for dipping your feet in. And one of the other things it allows is Kubernetes itself can't node autoscale. Kubernetes has no like it controls the pods, doesn't control the nodes, right? So if you fill up a Kubernetes host and it has no more resources, when you try to schedule new work, Kubernetes will just say, we're out of resources. With Container Engine, you can set them to be auto-scaling. So your nodes will scale as your usage goes up and down. You can scale up and down. So with the pod auto-scaling, you can have Kubernetes keep putting pods until it uses up all your resources. And then with node auto-scaling, you can hit that limit and keep going and add more resource to it. And then it can also shrink down. It can go both ways. So basically really tailor your computing resources to how much you're actually using them. So we also have container registry, which is a hosted hosted registry. You can make stuff private, but they don't have to be. You can make them public too. And you can use it with Container Engine or else. I use it all the time with just Docker. So just running Docker, I'll pull from container registry instead of from Docker's registry. And then Container Builder, which is, it's one of those things, I didn't think it was that cool until I started really using it. And I'm like, oh, this is actually so much more useful than I think it could be. So I'm going to try to explain why I think it's useful. So Container Builder will build images for you. So you're familiar with, you go to, you write a Docker file, you say Docker build to create the image, and then you say Docker run to run the image. Kubernetes is the same way, you have to put it in a repo instead of just running the image locally. What Container Builder will do is you upload to us the Docker file and all of the necessary code for your app. We will build the image for you and put it in our container registry. Why this is awesome is because what you're uploading in that case, instead of moving around giant images, so the base Nginx, if I just take Nginx, nothing else, I just know it off the top of my head, so I can use it. It comes to about 50 megs, which it's actually pretty good for compressed, it comes to about 50 megs, which is pretty good for a container. But containers can easily get up to 200, 500 megs, and you're pushing them over the network. With this, you're only pushing a compressed version of your code over the network and your Docker file. So I was in Germany taking the ICE train, which is really great, but the Wi-Fi is terrible. And I had to make changes to one of my Kubernetes clusters. I was able to push images up really, really fast over the network because all I had to do was less than a meg of code that I'm writing and the Docker file instead of the whole thing. So this is really cool. And then it's really repeatable, right? Because you have one source that's building all your images for you. Okay, and it's fast. All right, so conclusions. We went through all of our stuff. Kubernetes is open source. We definitely want your help on the project. You can check it out at Kubernetes.io, GitHub, Kubernetes/Kubernetes. As I said, it's very active. Of course, like every open source project, you know what is not very active? Documentation pull requests, right? So if you want to get involved, if you want to dip your feet into an open source project, our documentation, we would love help. And there are plenty of issues in the issue tracker about that. Twitter account, and they're on IRC with channel Google Containers. So roadmap. Right now we're Kubernetes 1.8. It was released in September. Nothing too really bright and shiny about it, but there's some security enhancements, role-based access control, and TLS certification rotation, and some different workloads. The workload API became beta, the cron jobs became beta, and custom resource definitions got included. There's the blog post link was wrong, so I won't highlight it. Kubernetes 1.9. I used to try to predict what would be big in the next releases by reading the issue tracker for milestones, and I just given up. There will be new stuff in Kubernetes 1.9. What it will be, some stuff will go from alpha to beta, some stuff will get generally released, but it's hard to sort of predict what will be there. What we can predict is that it's supposed to be released December of this year. They are really good at hitting those. I used to make fun of them, and then after I started making fun of them, they hit every single one. And so if they say it's going to be out in December 2017, it will be out in December 2017. Maybe December 31st, but it'll be out. So if you like Kubernetes, you like what you hear, but what the hell am I getting into here? This is a lot of stuff. I don't even know, like I said, I don't even know if I want to run on top of Kubernetes, let alone run it. Container Engine can make dipping your toes in a little easier. We I forgot the name of my product. Google Cloud Platform, little jet lag. Google Cloud Platform, we have it's $200 for a year free trial credit. So you can, with $200, run a pretty good Kubernetes cluster for a significant portion of that year. depending on what you're doing and how many nodes you have and whatnot. So sign up for the free trial and try it on us. See if it works for you, and then do it on-prem, do it on AWS. I'm making a bet here that you'll try it on us and really like it, but who knows? But try it on us. Try it with our free trial. It's great. There's also Minikube, which I talked about running on your laptop. So it's Kubernetes/Minikube. It is a one-node Kubernetes cluster that runs on VirtualBox, and it's basically a whole bunch of scripts that'll run it and tear it down for you. It is great. There's a little bit of overhead in terms of handling it because you're running in a virtual host instead of running on the machine. But if you guys are familiar with Docker pre-native Docker on Mac, you know exactly what that experience is like, so it's definitely manageable. But it's also only one node, so if you want to experiment with nodes, you're not going to get the full experience. But it's definitely cool for dipping your toes in and fooling around with. So we have been developing on containers for the past 10 years. We run everything at Google on containers. Everything. Everything? Everything. Gmail, web search, maps, MapReduce, our GFS, our Colossus jobs, even on Google Cloud Platform, if you spin up a VM, that VM is running inside a Borg container. This was where this is really crazy. I was making fun of it before, right? But if you're running if you're running Container Engine spins up our VMs to be the Kubernetes cluster nodes. So if you're on Container Engine, you're in a pod that's in a VM that's actually running on another container inside another VM in Google, right? So it's just containers all the way down. We say we launch 2 billion containers a week. So we do a lot of this. We're comfortable in this world. And so we think, for our purposes, we think containers are the way to manage scale. We grew like some absurd number, like 10 times in the first 6 months we were in existence. And while it hasn't been quite that rapid the entire time, we grow a lot. We're doing a lot of things. We need to eke out every single cycle from every single processor that we have. So containers are the way that we manage that. Containers are the way that we manage scale. Does other things for us, makes deployments faster, makes iterating a lot faster, but scale is, I think, why we go to it. There are other reasons to go to it. I think that you should carefully consider whether running everything on containers is right for you. And I say this, and I want to stress this, you should consider it carefully, because I don't want you to take away from me that the Google guy said, like, oh, the Google guy just said you should run everything on containers. No, it's not what I said. You should carefully consider whether running everything on containers is right for you. Why? Well, so if you look at, like, here's your typical, this is bad, right? This is your LAMP app that just got moved to production. If you take that and you move it over to Kubernetes, that's crazy, right? I got a multi-node Kubernetes cluster to handle multiple versions of this code that I was handling just fine in this. But most of you don't do this anymore. If you do, we won't judge. It happens, right? You don't run like 20 LAMP boxes, right? You run some application machines with some back-end machines to handle that. Well, when we start to get here, this is where Kubernetes makes more sense, when I have this environment. So what it makes sense is, like, so you take Kubernetes and you run it, right? And then you load it up with as many containers as possible. You hit resource limits. Maybe I need to add more nodes, right? Then I just keep filling this up and filling this up and filling this up. So the thing that's hard to get around Kubernetes is that it's not a replacement for a system. It's a replacement for your data center, right? It's like you put all your eggs in one basket and then watch that basket. So keep that in mind. This is the type of organizational code change that makes containers and Kubernetes make sense for you. So if this is where you're headed, awesome, Kubernetes is the right choice. If it's not, carefully consider whether or not it's the right choice for you. With that, I'll say thank you. If you want to get in touch with me, ask me questions after this, I'm at tpryan on Twitter. There is the joined in. Please feel free to give me feedback either way. And then if you want this Prezzo, it's available on bit.ly tpryan/chaos. So that I'll say thank you. And thanks a lot, and I'll be around for questions.